Good morning, I am Ramakanth and I am here to discuss on the topic Constructive Cost Model 2, which is also known as cocomo2. Topic Constructive Cost Model 2 is a model that allows one to estimate the cost, effort, and schedule when planning a new software development activity. So, whenever you plan for a new software activity, you have to know about the cost, effort, and schedule. So Cocomo 2 will be helpful for you to know these three activities. And Cocomo 2 is the latest major extension to the original Cocomo, which is published in 1981, which is also known as Cocomo 81. It consists of three submodels, each one offering increased fidelity the further along one is in the project planning and design process. Listed in increasing fidelity, these submodels are called the application composition, early design, and post architecture models. So, application composition, early design, and post architecture models are the three subcategories in COCOMO 2. COCOMO 2 strategy. COCOMO 2 strategy deals with preserving the openness of the original COCOMO, key the structure of COCOMO 2 to the future software marketplace sectors described earlier, like key the inputs and outputs of the COCOMO 2 submodels to the level of information available, enable the COCOMO 2 submodels to be tailored to a project's particular project strategy. And here the purpose of COCOMO 2 is to mainly help for people reason about the cost and schedule implications of their software decisions. Major decision situations helped by COCOMO 2 are software investment decisions, when to develop, reuse or purchase, what legacy software to modify or phase out, setting budgets and schedules, negotiating cost and schedule performance trade-offs, making software risk management decisions, making software improvement decisions, reuse tools, process maturity and outsourcing. We have already discussed this, but this is just a review so that we can have some key points in mind. And COCOMO 2 models for the software marketplace sectors. COCOMO 2 capability for estimation, application generator, system integration and infrastructure. These are the three important estimations in COCOMO 2, and the two life cycles are early design and post architecture. The next slide, like early design, the application composition model suitable for projects built with modern graphical user interface builder tools, which are GUI tools based on new object points. The early design model, you can use this model to get rough estimates of a project's cost and duration before you determine its entire architecture. It uses a small set of new cost drivers and new estimating equations based on unadjusted function points or KS log. Now I would like to discuss about the post architecture. The post architecture model, this is the most detailed COCOMO 2 model. You'll use it after you developed your project's overall architecture. It has new cost drivers, new line counting rules and new equations. And there's a table below here which describes the required reliability, like it should be very low, low, nominal, high, very high and extra high. These are the different levels which are present in required reliability. These are used to indicate how the software's reliability is, like it is very low, low, nominal, high, very high or extra high. And the other things are database size, complexity, required use and documentation match to life cycle. So we are having these five categories in this table, and we are having like six different types of levels. Each are used to indicate a particular software's position in a particular characteristic. And is adjusting nominal effort. In early design model, the formula is to adjusting the nominal effort. It is PM adjusted equal to PM nominal into pi I equal to 1 to 7 EMF of I. And the post architecture model is PM adjusted equal to PM nominal into pi running from I equal to 1 to 17 EMI. So these are the important formulas you have to by heart regarding the early design model and post. And this graph is COCOMO 2 model stages, where you can see that whenever you start like phases and milestones, you'll be having different types of milestones like feasibility, plans and requirements, product design, detailed design, develop and test, like development and test, right? And you are having concept of operation, requirement specifications, product design specifications, detailed design specifications and accepted software. So we are using the three things which we had discussed earlier, like application composition, early design, post architecture. In the diagram you can easily understand that whenever you start the development process, it will be very high, and you while going on you will be decreasing it. The development effort estimate is like PM nominal equal to A into size power B. PM means person in months and A is the constant, and as like size is the size of software development. Units like KS law, that means units of thousands of source lines of code, and B is the scale factor here. B differ. If B is less than 1.0, the project exhibits economies of scale, and B equal to 1.0, the economies and diseconomies of scale are in balance. And B is greater than 1.0, the project exhibits diseconomies of scale. Software economies and diseconomies means, like depending upon this, the software is economically. Uh, and coming to this slide, it is resolution rating components. Here we'll be having different types of characteristics which can be indicated with different types of levels like very low, low, nominal, high, very high, extra high. Like risk management plan, and the schedule, budget, and internal milestones, and percent of development schedule devoted to establishing architecture given general product objectives, percent of required top software architects available to project, tool support available for resolving risk items, developing and verifying architecture situation, and level of uncertainty in key architecture drivers, mission, user interface, costs, hardware, technology, and performance, and the number and criticality of risk items. So if it's greater than 10, then it is given as very low in criticality of risk items, and if it is 5 to 10, then it is low, the criticality is low, and if it is 2 to 4, then the criticality is nominal, and 1, then the criticality is high, and if it is greater than 5 non critical things, then very high, and if it is less than 5 non critical things, then it is extra high. So criticality will be uh, like will be decline the criticality in like using the number of things that is going like greater than 10, 5 to 10, 2 to 4, and level of uncertainty in key architecture drivers. So if the level of uncertainty is extreme, then it is very low, and if the uncertainty level is significant, then it is low, and uncertainty level is considerable, then it is nominal. If it is very little, then it is extra high. And percent of required of software architects available to project. So if we require 20 people of software architects, then it is very low. If we require 120, then it is very like extra high. And the tool support available for resolving risk items, developing and verifying architecture situations will be given as little, some, good, strong, and full. If it is fully needed means it is extra high, and it is not at all needed means then it's very low. And getting into the next slide about the function points. We have discussed this function point in earlier classes also, like user function types are external input, external output, internal logic file, external interface files, external inquiries, and I would like to define all these things once. External input means count each unique user data or user control input type that enters the external boundary of the software system being measured, and the second thing is adds or changes data in a logical internal file. External output. Count each unique user data or control output type that leaves the external boundary of a software system being measured. Internal logic file. Count each major logical group of user data or control information in the software system as a logical internal file type, including each logical file example, each logical group of data that is generated, used, or maintained by the software system. External interface files are files passed or shared between software systems should be counted or external interface file types within each system. External inquiries, which are queries, count each unique input-output combination where an input causes and generates an immediate output as an external inquiry type. And here we are seeing the experience factory of cocomo2, which is will be providing like system objectives are functionalities, preferences, and quality. Corporate parameters are tools, process, and reuse. We'll be giving this to the cocomo2, and here cost, schedule, risks, all these are estimated, and if it is okay, then it is passed through. If it is not okay, we have to rescope it again. So the next part will be discussed in the next. Like if it is yes, then what happens? If it is yes, then the project will be started execute project to next milestone. And if this milestone results in a positive thing, then it will go to direct done, and then it will keep on executing it is repeated until it is executed exactly what we need, until we get the result. So the milestone expectation, if it is if the milestone is not reached, if it is no, then we have to revise the milestones again, we have to plan again, and we have to take the resources again. After revised expectations, after it is revised, if it is okay means it's again go for done, and then the process will be done. So this is the architecture of cocomo 2 expense factory. And agile cocomo 2, this is one of the other cocomo version, which is a web-based software cost estimation tool that enables you to adjust your estimates by analogy through identifying the factors that will be changing and by how much. Like I had already given the link here, so if you go to that link, you will be knowing about that in briefly. And thank you. I think you had some information from the slides. Thank you.